Hey, what's up everybody? My name is Moss and welcome to this tutorial series on GitLab. In this tutorial series, I'm going to teach you how to utilize some of the core features of GitLab. In this video, I'm going to walk you through the roadmap of topics that we're going to cover in the tutorial series, as well as the learning objectives and who this course is made for. I'll also cover the first and second topics of this course in this video as well. So without further delay, let's dive right in. So for the first topic of this video, we are going to be answering the question, what is GitLab? And then I'll walk you through the basics of Git. But before I do that, let me introduce myself. My name is Moss, and I'm an experienced DevOps engineer with over 6 years of experience in industry. Now let's take a look at the roadmap of topics that we'll be covering in this tutorial series. As I already mentioned, our first topic will be answering the question, what is GitLab? Then I'm going to walk you through the basics of Git, and after that, I'll introduce you to the major components of the GitLab interface. Once you're comfortable with the GitLab interface, I'm going to introduce you to the basic workflow in GitLab called the GitLab flow. And once I've given a high-level overview of the GitLab flow, we'll perform hands-on activities that utilize the GitLab flow. We'll then dive into more advanced topics, starting with how to do CICD in GitLab. I'll then show you how to migrate your Jenkins Pipelines to GitLab CI. After that, we'll explore GitLab's packaging and releasing features. And finally, I'll show you how to integrate the Lambda test platform with GitLab CI to perform cross-browser testing. Now let's quickly go over our learning objectives. The first learning objective is to give you an introduction to GitLab CI. You will also learn the fundamental commands of Git. You will know how to work in GitLab using the GitLab flow. You will also understand and be able to perform CI/CD in GitLab. You will know how to migrate your Jenkins pipelines to GitLab. And you'll learn how to deploy software using GitLab's packaging and releasing features. So who is this course for? This course is made for DevOps engineers, software teams who want to migrate from Jenkins to GitLab, and developers whose team uses GitLab. The prerequisite to this course is that you have access to GitLab or a private instance of GitLab. So you should have a user account on whatever GitLab instance that you're using. You will also need a recent version of Git installed on your machine. Now let's get into the first topic. What is GitLab? GitLab is an open source software development platform. And at its core, it is a source code management system. But it also offers additional functionality like CI/CD on top of being a source code management system. And as you can see on the right, GitLab describes itself as a DevOps platform. So what's the difference between Git and GitLab? Git is a version control system. You use Git to keep track of changes made to source code files in a code base. In contrast, GitLab is a source code management system. So you would use GitLab to host Git repositories so that they can be shared with other people on your team. Similar to how you might upload and share files to Dropbox or Google Drive, you're doing the same with GitLab but for source code. So why use GitLab? GitLab enables collaboration among software teams with the GitLab flow. GitLab also has built-in CI/CD functionality. GitLab is highly interoperable and it can integrate with other tools. These are just some of the features that GitLab offers, but there are a plethora of other features. Now that we have a high-level understanding of what GitLab is, let's dive into our next topic. Okay, let's get ourselves up to speed with some basic Git commands. This might be a refresher if you're already familiar with Git, but if you're not, let's go ahead and verify that you have Git installed on your machine. I currently have my terminal open, and to verify my installation of Git, I'm going to invoke Git, and I'm going to pass in the -- version option, and this will return the version of Git that is installed on my machine if it's installed. And as you can see, I have Git version 2.33.0 installed. So the first Git command that we should cover is the git init command. And if you don't pass any parameters to the git init command, it will initialize the current directory as a Git repository. So if I were to execute the git init command as it is right now, it would initialize the Lambda test folder as a new Git repository. And it makes sense to use git init like that if you have a pre-existing code base that you want to check into version control and initialize as a new Git repository. However, if you didn't have a pre-existing code base that you wanted to initialize as a Git repository, then what you would do is you would pass the desired name of the Git repository that you want to initialize as an argument to the git init command. And that's the option that we're going to use. And let's call our Git repository test-project. Okay, and what this is going to do is it will create a subdirectory under the Lambda test directory, and that directory will be called test-project, and that will be our Git repository. So I'm going to go ahead and execute the git init command, and you can see at the bottom here it says initialize empty Git repository, and then it specifies the path of the Git repository. And then directly above that, it gives us an informational message about the name of the default branch in our Git repositories. And it gives us a couple of commands to rename the default branch in our repositories. So let's go ahead and do that. Let's execute the first command here, which is git config -- global init.default branch. And then let's set the default name to the default branch of our Git repositories as main. And then to execute the second command, we need to change directories into the Git repository that we just created. So I'll go ahead and cd into the test project directory. And then to rename the branch of our current Git repository to main, we will execute git branch -m and then the target name, which is main. So if we take a look at the test project directory, it should be empty. Let me clear the terminal real quick. And if I do an ls, there's nothing in the test project directory. If I do an ls-al to see the hidden folders in the directory, you'll see a hidden folder called .git. And the .git directory is what makes the test project directory a Git repository. Without the .git directory, the test project folder is just a folder. It is not a Git repository. It's not tracking changes to any of the files within the test project folder. So if I wanted to verify that the test project directory is a Git repository, I can look for the .git folder, and I can also do a git status inside of the directory, and this will also tell me whether or not I'm in a Git repository. And as you can see from the output of the git status command, we are currently on branch main, which is the default branch that was created when we use the git init command. And then it says that there are no commits yet, so we haven't generated any new git commits in this repository. So this repository is essentially a blank slate. It has 0 git history yet. And then in the last line of the output, it says that there's nothing to commit. So the git status command essentially tells us what the current state of our Git repository is. So if we've added any new files to the test project directory or changed existing files within the test project directory, when we perform a git status will show all of those changes in the output. Git status is a very useful command, and you'll find yourself running git status very frequently when you're using Git and working inside of a Git repository. Now, this Git repository isn't very useful to us if there aren't any files in the project that we want to version control. So what we can do is add new files to the test project directory and commit those new files on the main branch. But if we do that, then we're not taking advantage of one of Git's most powerful features, which is branching. So what's important to know is that the main branch in a Git repository, and it's not always called the main branch, sometimes it's called the pristine branch or the stable branch, is a branch that is supposed to be code that has no bugs in it. It's supposed to be deployable code that can go to the customer. And because of that, if you're a developer who wants to work on a new feature, working on the main branch is dangerous, because while you're working on that feature, you might commit some changes that cause other parts of the code base to break. And if the main branch breaks, that breaks the code base for everyone, not just for you. So it's really important to understand, as a developer, you should never be committing changes directly to the main branch of your Git repository. So if you're developing a new feature in a Git repository, you always want to make sure that you're not developing that feature on the main branch. You should be developing it on its own dedicated branch. And you can think of a branch in Git as an entirely separate copy of the code base. It's a copy of the code base that you can work on and experiment in and develop your feature in without having any impact on the main branch of the code base. So you would develop your feature in this branch or this copy of the code base, and once you've completed your feature and you're confident, you've ran tests on the feature and you're confident it can be merged into the primary version of the code base, you can actually use Git to merge your branch and your feature into the main version of the code base. So we are going to follow the best practice of creating a branch in order to make changes in our repository. But before we can actually create a branch, we do have to generate some history. So right now in our Git repository, we have no commits made in the repository. So we have to make at least one commit in the repository so that we can create a new branch and use that branch to develop a feature. So what I'm going to do is create a new file in this Git repository. And I'm going to create it using Vim. So I'm going to invoke Vim, and feel free to use a different editor if you prefer a different editor. But I'll call the file hello.txt. Okay, and inside of this file, we'll simply say hello. Okay. So if I do an ls, you can see that we now have the hello text file in our Git repository. And how does adding the hello.txt file change the state of our Git repository? Well, we can check the state of our repository using the git status command. So I'm going to do git status. And you can see now we have a little bit different output in the git status command. It says that we're on branch main. There have been no commits made to this repository. And then there is one untracked file, and that is the hello.txt file. And Git is really useful in that it suggests commands to use to progress through the workflow. And it says use git add and then the file name to include in what will be committed. So what is the git add command, and what does it mean to add a file to a Git repository? And to answer that question, I'm going to pull up the Git documentation in my browser. And I'm already at the target page, and just for reference, I'm at git-scm.com. So in Git, there is a concept of a two-stage commit. And what that means is that in order to commit changes to Git repository's history, which means make a commit object. A commit object is what tracks a particular set of changes to a Git repository. We have to use this two-stage commit, and this two-stage commit process. And it begins with adding changes from what's called the working directory into the staging area. And if you're wondering, well, how do I know whether or not my changes are in the working directory or if they're in the staging area? It's pretty easy to check where your change is at using the git status command. If I take a look back at my terminal, from the git status output, we can tell whether or not a change is in the working directory or if it's in the staging area. If it's in the working directory, those changes will show up in red as they do here. So this change is currently in the working directory, and we want to move it to the staging area. And what the staging area allows you to do is commit changes that are logically related to each other. So in the working directory, you can make changes to whatever files, and you can make unrelated changes within files, but you don't have to commit all of those changes at once. What you can do is you can stage those changes, the changes that are logically related to each other, before actually creating a commit object. And creating well-formed commits is actually very important to do. So in order to move changes from the working directory to the staging area, we have to use the git add command followed by the argument of the git add command are the name of the files or the directories that we want to add to the staging area. And then from the staging area, in order to create a commit object, we would use the git commit command. So let's go back to our terminal and add our hello.txt file to the staging area. So to do that, I'm going to say git add hello.txt. Okay, and it doesn't provide any output from that command, but it did execute successfully, and we can confirm that by running the git status command again. So now our hello.txt file is in the staging area. And how do we know it's in the staging area? Well, any changes that are currently staged will show up in green. And you can see here that Git recognizes that it's a new file that has just been added to the repository. And in order to commit this file to Git's history, we would use the git commit command. And we can also unstage this file as well and move it back to the working directory. And Git tells us how to do that. We can use git rm -- cache and then the file name to unstage this file. But we won't unstage this file. We are going to follow through with the two-stage commit process. And to do so, we will invoke git commit. Okay, and if we invoke git commit by itself, what it will do is it will bring up the default Git editor and prompt us for a commit message. And a git commit message is essentially a description, a very concise description of the change that we're making. So it's metadata on the changes that we're making to the Git repository, so that later on, if someone wants to review the changes made to the repository, they have concise summaries of all of the changes that have been made within a single commit. So we can use git commit without any arguments or options, and if so, it'll invoke your default editor. And in my case, it should pull up Vim, and it does, and it prompts me to enter a commit message. But the other option, without pulling up the default editor, so if I exit Vim and do git commit, I can use the -m option, and this way I can actually pass my commit message in line with the invocation of the git commit command. So if I wrap it in quotes, I can then pass in my commit message directly at the command line. And this is the option that I'm going to use. And in my commit message, I'm simply going to say adding hello.txt, okay, and end quotes, and then I hit enter. And in my case, it does give me a confirmation message that a commit object was created. But if this is the first time that you're using this Git installation on your machine, then when you invoke the git commit command, it will probably ask you to enter a username and email address for your Git configuration, so that when it creates the commit object, the metadata related to who committed those changes and who was the author of those changes will show up with your information. In my case, I already have those configurations set, but if you want to set those configurations now, you would simply say git config and pass in the -- global option, and then we'll say user.name, and then you can pass in your name. So in my case, I would just say Moss, and then we can also say git config -- global user.email, and then you would pass in your email, same as the username. I won't reset my email since I have it already configured, so I'm going to do a Control-C. And now that we have a commit generated in the repository, we might want to review the history of the repository at a later date. So how would we do that? How would we take a look at the commit that we just created? Well, to do that, we can use the git log command. So if I invoke git log just like this, it will show a list of all of the commits that have been made in the Git repository. So I'm going to go ahead and hit enter. And in the output of the git log command, we can see all of the metadata related to a commit. So in our case, we only have a single commit. And on the first line here, you can see the hash of the commit object. And the hash is the unique identifier of that commit object. And directly next to the hash of the commit is this head and then the arrow pointing to main. What this is saying is that the main branch is pointing to this commit. So essentially the main branch is up to date with the latest version of the repository. And then head and the arrow here pointing to main, this simply means that we're currently checked out to the main branch. If we made changes to the repository, if we made new commits on the repository, it would be associated with the main branch. And then below that line, we have information on the author, and this is information that would have been configured using these commands. So I have the author name and the author email address, and then below that is the creation date of the commit, okay? And then directly below that is the actual commit message that we provided in line when invoking the git commit command. Okay, so now that we've created our first commit in the Git repository, when I perform a git status, we shouldn't see the no commits message in the output of the git status command. And as you can see, we don't see it. All we see is that we're currently on branch main and that there is nothing to commit, and the working tree is clean, meaning there's no changes in the working directory that could be added to the staging area. Now, if we want to make any additional changes to the Git repository, what we should do first is create a branch so that we can work on those changes on a separate branch that isn't the main branch. So let's say I want to modify the hello.txt file, and I also want to add a new file to the Git repository. So the first thing that I want to do is create a branch, and to create a branch, I can use the git branch command. And then as an argument to the git branch command, I can pass in the name of the desired name of the branch that I want to create. So let's call this branch my-feature, and then I'll hit enter. So that just created the branch, and I can confirm that it created the branch by just invoking git branch without any arguments. And you can see that two branches are listed in the output, the main branch and then the my-feature branch. But notice something is that the main branch is highlighted green with this asterisk. And what that means is that we're still working on the main branch. If we were to make any changes right now, add any new files, those changes would be added to the main branch if we were to commit them. So what we need to do is we need to check out to the my-feature branch. So in Git, we call it checking out to a branch. And before we check out to the my-feature branch, let's run git log one time. And you can see in the git log output, now not only is the main branch listed in the output, but also the my-feature branch. And both of the branches are pointing to the same commit right now. But also notice that the head pointer is currently pointing to main, which means that we're working on the main branch, and any changes that we make would be committed to the main branch, and they would not be applied to the my-feature branch. So let's go ahead and check out to the my-feature branch, and to do that we can use git checkout and then the name of the branch that we want to check out to. So I'm going to say git checkout my-feature. And it says in the output that we switch to branch, my-feature. And if I run a git status, you can see that we're currently on branch my-feature and that there is no changes to commit. And also if we run git log again, not much has changed, but notice that the head pointer is now pointing to the my-feature branch, and it's no longer pointing to the main branch, which further confirms that we're checked out to the my-feature branch. And any changes that we make at this point and commits that we create will be associated with the my-feature branch, and they will not be applied to the main branch. So let's add some new changes to our Git repository and practice the two-stage commit process. So the first change that I'm going to make is to the hello.txt file. So I'm going to open it in Vim, but feel free to use whatever editor you prefer. And I will simply add world, so it'll be hello world, and we'll save it. And I'll do a git status. And you can see in the working directory, Git prompts me, it says changes not staged for commit. And then it shows here, instead of new file, it shows that the hello.txt file was modified. And we can either use git add to add those changes to the staging area, or we can use git restore and then the name of the file to discard the changes. In this case, it would remove the word world from the hello.txt file that we just added if I were to run git restore and then the file name, git restore and then hello.txt. And then for the next change, I'm going to create a new file and I'm going to call it tests.txt. And I'm going to say unrelated change. And I'll save it. And then I'll do git status again. So the test.txt file is a new file, which means it's going to be listed under untracked files. Git currently is not tracking the test.txt file. In order to track this file, we have to add it to this Git repository's history. And to add it to the history, we have to make a new commit. Now remember that I mentioned that we can stage logically related changes together so that we can create well-formed commits. And it might be the case that the change that I made to the hello.txt file is unrelated to the addition of the test.txt file. So I might want to commit these changes separately. So let's exercise the staging area and commit just the changes made to the hello.txt file, and then we'll create a separate commit for the addition of the test.txt file. So to add the changes made to the hello.txt file to the staging area, I would say git add and then hello.txt. And then if I do a git status, we can see that the changes made to the hello.txt file are now in the staging area. And then when we invoke git commit, it will only commit the changes that have been staged to Git's history. So if I say git commit -m, and then we'll say modifying hello.txt, I'll hit enter. So it created a new commit, and then if I do git status, the change where we added the test.txt file to the repository is still in the working directory. And if I perform a git log, we should see 2 commits in this Git repository's history, and we do. And notice now that the branches are not pointing to the same commit anymore. The main branch is pointing to our first commit in the repository, and the my feature branch is now pointing to the latest commit made in the repository where we're modifying the hello.txt file. So now let's add and commit the test.txt file. So I will say git add test.txt and then git commit -m, and we'll say adding the test.txt file. Okay, so that created a second commit. So now we have 2 commits on the my feature branch. So if we list the files in the test project directory, we can see the hello.txt file and the test.txt file. And if I were to cat the hello.txt file, we can see the contents of the file and it says hello world. So this is the latest version of the hello.txt file on the my-feature branch. If we were to check out back to the main branch, you'll notice that the directory structure gets updated as well as the hello.txt file. So let's go ahead and check out to the main branch. So I'm going to use git checkout and then main. And it says that we've switched to the main branch. And I'll confirm with git status as well. And it says that we're on the main branch here as well. So if I do an ls you can see that the test.txt file is no longer listed in the directory because on the main branch, the test.txt file hasn't been created yet. And similarly, if we cat the hello.txt file, you can see that it's the older version of the hello.txt file that doesn't say hello world. So while we made changes on the my-feature branch, the history of the main branch has remained intact. Nothing has changed on the main branch. We've only made changes on a separate branch, which remember we can kind of consider almost like an entirely separate copy of the code base. It's an isolated space where we can make changes and experiment without impacting the main version of the Git repository. But if we're satisfied with the changes that we've made on that branch, then what we can do is we can merge those changes and those commits into the main branch. And to merge a branch in Git, we want to be checked out to the target branch, and then we'll specify the source branch that contains changes that we want to merge. So currently we're checked out to the main branch. If I do a git status, we can see that we're checked out to the main branch, and the main branch is the branch that we want to merge changes into. So now that we're checked out to the main branch, we can use the git merge command to merge the changes from the my-feature branch into the main branch. And the only argument that we need to pass to the git merge command is the name of the source branch, which in our case is the my-feature branch. And real quickly, before we execute the command, I want to do a git log, and I'm actually going to pass in the --all option and the --1 line. And --all will show us the history of all branches in the Git repository, and --1 line will give us a nice one-line summary for each commit in the repository. Okay, so there's 3 commits in total, and you can see that the my-feature branch is pointing to this commit, and then the main branch is kind of behind. It's pointing to the first commit that was made in the repository. So when we perform a git log after executing the merge, we should expect to see the main branch pointing to this commit. So let's go ahead and execute the merge. I'm going to say git merge my feature, and it gives us kind of a confirmation message saying that it performed a fast forward merge, and we have a new file, test.txt, and a couple of lines were changed in the hello.txt file. And we can also confirm this by performing an ls, and we can see that the test.txt file now exists in the test project directory. And if I cat hello.txt, we can see it's the latest version of hello.txt, which includes hello world. And finally, let's check the history using git log. Actually, I meant to use git log with the one-line option and --all. Okay, so now we can see in the output here that the main branch is pointing to the same commit that the my-feature branch is pointing to. So it includes the changes contained in both of these commits. And since the changes that were made on the my-feature branch are now merged into the main branch, there's really no need for the my-feature branch. So I'm going to delete that branch, and I can do so using git branch -d and then my-feature. Now there is one more very useful git command that I'd like to show you. So I'm going to go ahead and clear the terminal. And the command is git stash. The git stash command allows you to experiment with various changes and save those changes without actually committing them to the Git repository's history as a commit. So to show you what I mean, I'm going to make a modification to the hello.txt file. So I'm going to open it up, and I'm going to add a word here. I'm just going to say hello world testing, and I will save the file. So I'm going to run git status, and we can see in the output that the hello.txt file has been modified, and we can stage that change to be committed, or we can actually stash that change where we added the word testing to the hello.txt file. When I use the git stash command, I'm taking all of the changes that are in my working directory and I'm stashing them away in a reserved location that's outside of Git's history. And to stash our changes to the hello.txt file, I can either say git stash or git stash push, and that will stash the changes made to the hello.txt file away. So I hit enter and it says saved working directory and index state work in progress on the main branch. And if I perform a git status, you'll notice that I have a clean working directory. That change no longer exists in the working directory, and if I cat the hello.txt file, the testing word is not included in the hello.txt file. That change that I made still exists, but it's been stashed away. And to see that change, I can use git stash list, and it will list all of the changes that have been stashed by Git. So I can see my change in the stash at position 0. And if I want to reapply that change to the working directory, I can either use git stash apply or I can use git stash pop. And there is a difference between these two commands. When I use git stash apply, it will reapply the changes to the working directory. And you can see here that now hello.txt is modified. If I cat hello.txt, I can see the word testing in the file now. But it will not remove this change from the stash. So if I do git stash list again, I can still see that change listed in position 0. The only difference between git stash apply and git stash pop is that git stash pop will actually pop this change off of the stash so that it is no longer listed in the stash. So if I perform a git stash clear, it will clear all of the entries in the stash. I still have my change applied in the working directory. I'll stash this change again, but I'm going to use pop instead of apply. So git stash push and then git stash list. Okay. And then I'll do git stash pop. Okay, and it shows that the hello.txt file has been modified. And if I do git stash list, you can see that that stash entry has been removed. In later videos, we'll explore a few more Git commands, but at this point, you're ready to start working with GitLab. And in the next video, we'll introduce you to some of the major components of the GitLab interface. If you'd like to learn more, be sure to follow our blog at lambdatest.com/blog, as well as our Lambda Test community at community.lambdatest.com. You can also earn resume-worthy Lambda Test Selenium certifications at lambdatest.com/certifications. See you in the next video.